a little tilted, though, I think. Let's straighten that out. There we go. Better? I don't know.
Now, I watched myself last night. That's a bad idea. Never watch yourself. It's really bad. But I figure you're learning stuff anyway, even if it is bad. Okay, so in this case, I'm going to fail doing cluster analysis. I'm going to get the wrong answer. The wrong answer is worse than just getting noise, because it says there are two clusters, but they're not the two correct clusters that we can see. But if I told it to do 4 clusters, that's not necessarily true. Sometimes you tell it the number of clusters you want, and other times you don't. And we'll talk all about that. But suppose that I am telling it the number of clusters, and I tell it 4 clusters instead of 2. Then it's going to get it right. It's going to say, there's a cluster here. If I tell it 4 clusters, it's going to say this, and this, and this, and this. And it's going to not be so good about the border between those, but we don't care. But it's going to get 4 clusters. And because these points are closer to each other than the ones over there, all of a sudden, it gets the right answer again. Even though it doesn't get the border between those two, but who cares? So the number of clusters that you choose in the procedures that require you to choose the number of clusters is important. Of course, this is in 10 dimensions, and you don't know how many clusters you have. So it becomes challenging. Maybe I'll randomly generate this data so that we can play with what happens with the different cluster analysis procedures. Okay, here's what happens in cluster analysis. I really don't like this view. Okay, we'll be okay. We're going to take the data points, which statisticians like to call experimental units, and we're going to make clusters of the points, not new variables. It's got nothing to do with the number of variables. There could be 10 variables, 2 variables, or 20,000 variables. It doesn't matter. So, but we're going to group the points together, like we've been playing with up here. That cluster analysis does its job. It's going to group the points together. Whether you like it or not, you asked it to group the points together, and that's what it's going to do. So if you give it 1, 2, 3, 4, 5, 6, and you tell it you want 2 clusters, it's going to divide it into 2 clusters. That doesn't mean that there are 2 clusters. It only means you told it that you wanted 2 clusters. So noise gets clustered together. There are many, many hard problems for cluster analysis. So this makes me think of the fact that, well, what happens if you have a nice tight cluster down here, and then you got a whole bunch of noise up here? What's it going to do? That's really hard for cluster analysis. What if this cloud is on top of this cloud? This is the nucleus. So you got all this noise around here. Talk about hard. Cluster analysis has got no idea what to do, because you got all this noise on top of it. There's a signal in here. There's a bunch of points right in here. I have no idea how cluster analysis would I'll have to think about how that might be. Can you have a cluster within another cluster? Not really. The math doesn't work that way. These points are close together, but there's all this noise around them. So it's not going to, what if you have a multivariate mountain? I can think of all sorts of things. You can draw any number of pictures about what's going on in your data that will confuse cluster analysis. Doesn't mean it's not useful. It doesn't mean you shouldn't run a cluster analysis on your data. Just please be careful about what you're doing. And I'll talk a lot about how to make sure that your answer is real. If you say there are 3 clusters, you better have multiple evidence and strong evidence that you really have 3 clusters. If you have 3 clusters, then yes, you gotta have some evidence of that. You can't just say, oh, I grouped it into 3 clusters and then start talking about them. No, that doesn't work well. And I have numerous examples because the gene expression people love their clusters because they like to cluster the genes together, and it makes incredible biological sense. Genes are similar to each other. They act together in pathways, and there's a huge amount of biological research that says that this happens. They interact with each other. They should cluster together. And so they run cluster analysis, and then they make up nonsense. I shouldn't say that. They try to figure out what the cluster analysis means. And most of the time, they just confuse themselves. And the reason they confuse themselves is because what happens if you have this situation right here? I think this might be what's happening. Maybe I can show them why they get in trouble, because there's all this noise mixed in with their signal. And cluster analysis doesn't know the difference between noise and signal. It's not designed that way. It's not a statistical procedure. It's a mathematical procedure. It's actually, I don't even want to call it mathematical. Computer scientists love cluster analysis because it's all algorithms. It's all, which points are closest together. That's a computer science question. And they they compete with each other on how fast they can cluster. Like, really? We want useful clusters. They only want to find them. Okay, if you're going to, back to the notes. If you're going to do cluster analysis, you have to decide how far apart 2 points are. You would think that this is a simple question, but it's not. The number of there's lots of different distance measures, especially when you're talking about the distance between 2 clusters. The distance between 2 points, we kind of like to use Euclidean distance. The distance between those points is straightforward. You learn in kindergarten, in geometry class or something. It's the square root of this distance squared plus that distance squared, and you go, oh, the distance between them. Or, call it the ruler distance. Use your ruler to measure. You're going to get the right answer. That's what distance means to most people. But if you have 2 clusters, so we have 2 clusters here. How far apart are those 2 clusters? There's an almost infinite number of ways to measure the distance between those 2 clusters. Fortunately, if they're real clusters, they're almost all it doesn't really matter what you choose. If they're not real clusters, then it matters a lot what you choose. So the different methods for choosing how you measure how far apart these are impact the answer. And hopefully they don't impact the answer too much. But if your data, instead of looking like this, looks like this, then one method of measuring distance may get, and we're going to make 2 clusters, one method may get this, 1, 2 clusters. But another method may get this, 1, 2. And another method might get this, and all this. It's like, what are you to do? Conceptually, if there really are two clusters, then the methods should get sort of the same answer, pretty much. But you have to tell the software how you're measuring distance. It's not something that you can, you got to tell it. There's no choice no choice. The choice is that you have to make a choice. You can't just, and you can choose the default. I don't know what the jump default is. It doesn't matter. But the default might not be the best. In fact, it's probably the most popular, which may be nothing like the best or what's best for your situation. In reality, what you do is you choose different distance measures and you hope the answers are the same. And if they're not the same, you learn something about your data. That you've got different answers using different approaches. Some methods depend on how many clusters, some methods of deciding. Okay, sometimes you have to decide how many clusters you have. This is frequently an impossible task. I can't see the data in 10 dimensions. How do I know that I have 3 clusters? Well, of course I don't. So how do when the software says, well, how many clusters do you have? I don't know. 5. Why 5? I don't know, because I had to decide. But that's, in some of the methods, you have to decide that. And that's